Now we're going to start to look at the periodic table. And as we move through this, we'll look at the trends that we see as we go from element to element. So fill in your notes as you move along and pay attention to the extra things that I say. All right, this is how they really make. No, that's just Tetris. All right, so anytime you have a periodic table, you're going to see one of the squares. And the squares generally look the same, where you've got the average atomic mass, and remember that's the average of all of the known isotopes. Okay, and we talked about that being the protons and neutrons, but it's an average. You have the element symbol. The first letter is always going to be capitalized. The second will be lowercase. Make sure you understand that. You have the element name and you have the atomic number. And the atomic number is going to represent the number of protons in an atom. In a neutral atom, it will represent the number of electrons. All right, so Mendeleev was the father of the modern, or of the periodic table, the first one. He organized his elements in rows by increasing atomic mass, and he noticed patterns among the elements. He actually published the first periodic table in 1869. His periodic table looked like the one on the bottom left. It doesn't look really similar to the one that we have now. He started a new row every time the properties of the elements repeated. So elements in the same column have similar properties. His table was used to predict how elements would behave that had not been discovered. So if you notice down here in this area, there are a bunch of blanks, and he left the blanks there so that the ones that would be discovered would go there. So we have the element mendelevium, and it was named in honor of him. All right, so here are some properties of the elements, and you'll learn more about this when you get to chemistry. In 1913, Henry Moseley corrected the discrepancies Mendeleev had with some of the properties of some elements fitting in with their assigned groups. He arranged the elements by their atomic number or number of protons. And this is how our periodic table is arranged now. So here's a question. How is Mendeleev's periodic table arranged? Was it by increasing atomic mass, decreasing atomic mass, increasing atomic number, or decreasing atomic number? His was by decreasing atomic mass. Should be increasing atomic mass. All right, so the modern periodic table. Periodic law. When the elements are arranged in order of increasing number of protons or atomic number, the properties tend to repeat in a certain pattern. All right. So the periodic table is similar to a store. In a store, you're going to find items that are similar, and they're going to be grouped together so they're easier to find. So if you go to Target, or even let's talk about Kroger. So if you go in the grocery store, you're not going to find the fruits with the canned goods. You're going to find the fruits and vegetables all together. And then you're going to find the frozen foods in one section. If you go to Target, you're going to find the men's clothes in one section, the toys in one section. Okay, the periodic table is really similar. Elements are arranged in a certain order based on the number of protons an atom of an element has. The table is going to put the element into groups with similar characteristics. It allows us to recognize trends over the whole array of elements. And we're going to talk about these trends as we move through. Okay. So here are some of the trends that you can look at. And here's your periodic table. Make sure that you have your hard copy of a periodic table. I've posted one on Google Classroom if you need one. So the atomic mass and the atomic number is going to increase as you move across and down. So if I start over here, I have an atomic mass of 1.0, and as I move across and down, my atomic mass is going to increase 1.3129, okay? Even if I move across. Same thing with the atomic number. Let's start here. 19, as I move across, it increases. As I move down, it increases. All right, atomic radii. The atomic radius is going to actually decrease from left to right. Down a group, the radius is going to increase. The greater the number of protons present, the stronger the attraction that holds the electrons closer to the nucleus and the smaller the size of the shell. This is actually going to be extra information for you, but it's good food for thought. All right, a period. This is really important. A period is a horizontal row of elements in the periodic table. The protons and electrons increase as you move across a period from left to right. The period is going to show you how many energy levels the atom has. So a horizontal row, if you row your boat, you go across, not up and down, you go across. And this shows how many energy level the atom has. So when we draw the element and we were drawing all of the electrons, we were drawing each energy shell. I can determine how many energy shells each element has based on where it's located in the row. So there are actually 7 periods on the row, or on the periodic table. Row 1 consists of 2 elements. Row 2 consists of these. This is row 3, row 4, row 5, 6, and 7. And now these have been taken out. They actually fit into 6 and 7, but they've been taken out because it makes it shorter. We'll talk about that later. So if I gave you sodium, sodium's right here. Sodium is in row 3, period 3. Sodium will have 3 energy levels. So when I go and I draw this, I know I'm going to have 3 circles to put electrons on. Hydrogen, if we were to draw all the electrons in hydrogen, it would only have 1 energy level. Same thing with, let's do oxygen. Oxygen is on the 2nd row, so oxygen would have 2 energy levels. If I went down here to this element, it would have 6 energy levels. All right, going through and showing you everything. Elements become less metallic as you move right across each period. So when we're looking at the metals and the nonmetals, the metals are going to be on the left, the nonmetals are going to be on the right. And as I move across the period, because they go horizontal, I'm becoming less metallic and moving into your metals, nonmetals. Your groups. So your groups are actually the vertical columns on the periodic table. Groups are also called a family. It's really important that you know both terms. Groups are also going to be called a family. These are going to have the same properties. So the horizontal rows, the elements have the same energy shells, and the groups are going to have the same properties. There are 18 individually numbered columns. Columns run vertically, up and down. Columns hold up your house. All right, here are your groups. There are 18 of them. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, through 18. And I'll go through and talk about these. All of the groups are going to have the same number of valence electrons. They're going to have the same number of valence electrons. So if you are in group 1, which is located on the left over here, you're going to have 1 valence electron. Group 2 will have 2 valence electrons. Now notice, do you see how there is a dip in the periodic table? This is where it's going to vary, and we're not, for this class, going to look at this very much. But let's move over to the right side when it comes back up. I am now in group 13. If I go back over here, it dips, and then I get into group 13. So group 1 had 1 valence electron. Group 2 had 2 valence electron. Group 13 is actually not going to have 13 valence electrons. It's going to have 3 valence electrons. Group 14 is going to have 4. 15 will have 5. 16 will have 6. 17 will have 7. And 18 will have 8. And if we notice, remember the rule of 8, if it's 8, it's full. These have a full octet, and they are called a specific group, and we'll talk about that in a second. All right, so there's the list of all the valence electrons. Okay, and here are the Lewis dot structures. And if you were in class, we did something with these. Just shows the valence electrons. Remember, valence electrons are outside electrons. So this one would be lithium. It's in group 1. It has 3 protons, so we know it's lithium. Here's another one. What element do you think that is? It has 1 proton. It's going to be hydrogen. All right. And beryllium is in group 2 because it has 2 valence electrons. So if it has 3 valence electrons, it would be in group 13. All right, the role of electrons. The chemical property of each group is largely determined by the number of valence electrons. That's why I said it was really important for you to understand the term valence electrons. And it's really important for you to memorize how many valence electrons are in each group. If you can count to 8, you can remember it. Now, there is one exception. Helium does not have 8 valence electrons. It only has 2 because it only is going to have 2 electrons. All right, so what group does this element right here belong to? It has 1 valence electron. Well, it's going to belong to group 1. If it has 1 valence electron, it's going to belong to group 1. And then we talk about valence electrons being located on the outermost energy shell. All right, your representative elements. These are what we call the main group elements, and those are the ones we're going to work with. They're the elements that are in columns 1 through 2 and 13 through 18, the highest peak columns. So what you're going to do to figure out the number of valence electrons is subtract 10 from the group number, unless it's lower than 10. So if I get to group 13, I take 10 away, there's 3 valence electrons. I just kind of memorize. Group 1 has 1, 2 has 2, 13 has 3, 14 has 4, and so on. All right, and then we talked about the octet rule this week. The octet rule, atoms tend to gain or lose electrons in order to obtain 8 electrons in the valence shell. The exception to the rule would be helium, because it already has 2. So if you know where the element is located, you can figure out how its electrons are arranged. All right, this is important. Okay. This is going to tell you your oxidation number, and it tells you what ions each of them form. So if we look, group 1 is going to form a 1 plus. So memorize this: 1 plus, 2 plus, 3 plus, skip, 3 minus, 2 minus, 1 minus, zip. I'll say it again: 1 plus, 2 plus, 3 plus, skip, 3 minus, 2 minus, 1 minus, zip. And so before, when we were looking at this, we were looking at ions, we were saying, we were drawing everything. It was becoming kind of redundant, okay? And so let's take lithium, for example. I can draw lithium. We'll have 3 electrons total. It has 1 valence electron. Well, I know it's in group 1, so it's going to have 1 valence electron. And so the kind of ion lithium is going to form, remember my rule of 8, is it going to be easier for lithium to gain 7 or to lose this one lonely electron right here? Well, it's going to want to lose that one lonely electron. And when it loses that one lonely electron, lithium has 3 protons. Now it's going to have 2 electrons. It's going to have a 1 plus charge because I have more protons than electrons. All of the elements in this group will form that kind of ion. Same thing, let's choose another one. Let's choose we'll choose fluorine. Fluorine, they already have the valence electrons drawn for us. Fluorine has 7 valence electrons. 7. So is it going to be easier for fluorine to lose 7 or gain 1? And fluorine's going to want to gain 1 to make 8. And when fluorine gains 1 electron, I'm gaining 1 negative. So I'm going to have 1 more negative than positive. That's going to form a 1 minus ion. So your ions should look like this. 1 plus, 2 plus, all of these. Remember calcium, we talked about that, has a 2 plus ion. And then I have 3 plus. I'm skipping this one. I skipped this one because 4 could go either way. It could be plus 4 or minus 4, so we kind of just say skip. And then I go 3 minus, 2 minus, 1 minus, zip. Zip is in 0. Okay, and it's zip because if you notice, all of these already have 8, so they are considered full. Memorize that, it'll help you. All right. So ions are formed by changing the number of electrons. Ionization is the process of adding or removing electrons from an atom. It happens to atoms that do not have their outermost energy levels filled with electrons. And so I've got 2 of them here. Got a neutral lithium atom, and it's got 1 electron. It's going to be easier for it to lose this 1 electron. And when it loses this 1 electron, notice it's now full, so it's going to form a positive ion. It's going to be a 1 plus. Okay, and then they use fluorine as an example. Okay. Now, there's 2 types of ions, and we've talked about these. So you just had a quiz over them. You have a cation, which is a positive ion. I'm losing an electron, so I'm going to have more protons than electrons. So I'm going to be positive. Okay, remember, cats have paws, so they are positive. Lithium is another as an example. It's the easiest example. So lithium has 1 more valence electron, so it would rather give it away than collect 7 to be full. And then you have an anion, and remember we say A negative ion. So anytime you add an electron in, you have more electrons than protons. And these are the groups in 15, 16, and 17. They use fluorine as an example. So fluorine has 7 valence electrons. It's easier to add 1 to make 8 than to lose 7. So if I'm adding a negative, I'm going to be overall negative. All right, so let's look at this. Identify the valence electrons, the oxidation numbers, and name the families. We're going to kind of look at this. Well, here's some examples. If I asked you how many valence electrons were in chlorine, so chlorine is down here. How many valence electrons are in chlorine? Chlorine has 7 valence electrons because it's in group 17. 1, 2, this is through 12, 13, 14, 15, 16, 17, 18. 7 valence electrons. How many oxidation number? What's the oxidation number? Okay, the oxidation number of this. Remember, rhyme 1 plus, 2 plus, 3 plus. I'm skipping. 3 minus, 2 minus, 1 minus, zip. The oxidation number would be 1 minus. It's easier to gain 1, okay? And then we won't talk about the family names just yet. Or what if I gave you calcium? Calcium is over here. How many valence electrons does calcium have? It has 2 valence electrons. What's the oxidation number? What kind of ions are going to form? It has 2 valence electrons. It's easier to lose 2 than to gain 6 to make 8. So it would be a 2 plus charge. All right, let's talk about hydrogen family. Hydrogen has one valence electron, so it's in the alkali metal family because it's in group 1. However, with hydrogen's kind of, it's a lone bird, okay? It's not really a metal, it's a gas, but it's over there because it has one valence electron. So all the other elements in this family, like lithium and sodium, for example, have one valence electron. Fluorine has 7 valence electrons, so it's going to be located in group 17. Every other thing in that group is also going to have 7 valence electrons. The name of this group is called the halogen family. The halogen family. Halogen means salt forming. So technically, if you take things from group 1 and things from group 17, and you put them together, you're going to form a salt. Sodium chloride is one of them that makes table salt, right? And so, like I said, alkali metals have 1 valence electron. Your halogens have 7. And what's going to happen is this one over here that has 1 is going to want to lose this 1 because it's easier to lose 1 than gain 7. And this one over here has 7 of them. And it's not going to want to lose 7. It's going to want to gain 1 to make it full. And so that's what will happen when that goes in. And so that's where I get sodium chloride from. And we'll talk about that when we get to bonding. But the most important part is that you understand the oxidation number tells you what kind of ion that is formed. All right, so we talk about ionization energy. That's just the energy required to remove an electron from a neutral atom. It's going to increase to the right and up. This isn't going to be on your quiz. All right, here we go. Let's talk about phases at room temperature. You need to memorize these. So we've got gases. There are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 gases on the periodic table. You're going to have to memorize them. Everything in group 18 is a gas. And then you go 2 and 17, 1 and 16, 1 and 15, and then hydrogen. So group 18 is called noble gases. They're all going to be gases. Fluorine, chlorine, oxygen, nitrogen, and hydrogen are your other two, or your other ones. And then you need to know where the liquids are. There's only 2 liquids on the periodic table. They are mercury and bromine. Mercury is actually the only liquid or the only metal that is a liquid at room temperature, and then everything else on the periodic table is a solid. So on your periodic table, make sure you write these on there. Make sure you understand where they are. Okay, so notice my gases are here. So I go full row, 2, 1, 1, hydrogen. And I kind of just memorize the shape of it. And then you need to memorize mercury, bromine are liquids. And everything else is a solid. Okay, we talk about reactivity. It's how likely it will react with other substances. It's really important to understand. Group 1 is going to be very reactive. This is the highly reactive metals. And group 17 is highly reacted nonmetals. Okay, remember they bond with each other. And so let's look. Here are your gases. Remember, whole group 2, 1, 1, 1. I have 2 liquids, mercury and bromine, and then the rest are solids. Okay, you don't need to know about the reactivity increasing and decreasing. And so elements in each category have similar properties. And we're going to talk about metals, nonmetals, and metalloids. Okay, your metalloids are also called semiconductors. So if you notice, your metals make up most of the periodic table. They're located to the left of the periodic table, with one exception, and that would be hydrogen, And the only reason hydrogen is on the left side is because hydrogen has one valence electron. Your nonmetals are going to be on your right, okay? And most of your nonmetals are gases. And then you've got your metalloids, and we'll talk about metalloids in a minute. They're kind of in the middle. They're semiconductors. So your metals, they're good at conducting heat and electricity. That's just a common thing for metals. Make sure you know that. They're shiny, they're malleable, which means they can be flattened into sheets. They're ductile, which means they can be stretched or shaped into wires. Most of them are solids at room temperature. There's one exception, and that would be mercury. They tend to lose electrons, which means they form positive ions. And you have examples such as copper and lead. Okay. So the metal families. Here you go. Group 1 is going to be your alkali metals. Group 2 is your alkaline earth metals. You have your transition metals, and now these are the ones that you need to know that they're the transition metals, but we don't really talk about them that much, but that's where that table dips down. Okay, your transition metals are going to be the ones that are used to make jewelry, like gold, silver, platinum. Now, bronze is not on here because bronze is an alloy, and we'll talk about that in a minute. Right, almost 75% of all elements are classified as metals. When we looked at it, basically the left side of the periodic table is metals. Okay, they're classified based on their physical properties: hardness, shininess, malleability, conductivity, magnetism, and ductility. Chemical properties: the ease and speed in which an element reacts with other elements is called reactivity. Metals show a wide range of chemical properties. Iron will react with oxygen, and then you've got gold and chromium that are unreactive. So they have a wide range of properties here. You have your alloys. Now, your alloy is a mixture of metals, and they combine the beneficial attributes of two or more. So actually, iron's going to rust easily, but when it's mixed with something else, it's going to form stainless steel. And then we talked about this a minute ago. Copper is actually soft and malleable, but when we mix it with tin, it actually forms bronze. And so when you're thinking about the Olympics, and the Olympics are coming up this summer, they give out gold and silver, which are pure elements, and then they give out bronze, which is actually a mixture of a couple of things. And we are actually going to stop there for today. So come back and watch part 2 for the rest of your notes.